Here are some practice problems and examples using the distributive property. Let's do the fill-in-the-blank portion first. The distributive property states that we must distribute whatever number or variable is directly outside the parentheses to every term inside the parentheses by multiplying. So when we're working with the distributive property, we're going to be using multiplication. Now that should be familiar with you. When you see parentheses, that should remind us to multiply. As we move through the practice problems, I want us to reflect on how each problem that's presented is going to get increasingly more difficult. So we're going to look at the complexity and how we're going to keep increasing that as we move through the examples. Okay, let's get started. Okay, we're going to distribute each number that's outside to each term inside. So distribute to each term. And we're going to be using multiplication. So our first step is 8 times 6m. 8 times 6 is 48m. Then 8 times 9 is 72, and it's a positive or a plus 72. That's all we do. These are not like terms, so we cannot do anything further. So moving over to our reflective column, what are your thoughts? Not so bad, right? We're going to multiply and make sure we know that they're not like terms once we multiplied. Okay, so I just made a note that we're multiplying by both terms inside the parentheses and my little smiley face because this one was pretty easy so far. So far, so good. Okay, let's go on to the next one and we'll see how this is getting increasingly more difficult. All right, let's distribute first. So we take the -6 and it goes to both terms inside the parentheses. Okay, -6 times 8x. A negative times a positive is a negative. So this is -48. Then a -6. Oh, and remember we can put an invisible 1 here if we want in front of the variable. So a -6 times -1y. A negative times a negative is a positive. So this becomes positive 6y. And that is all we can do. These are not like terms. We cannot simplify anymore. As we go over here to reflect on this one got a little more complex because we had negatives and we had to remember our integer rules. Okay, so in my reflective notes, I made a note that this example was more difficult because of the negatives. I had to remember the integer rules. And just to refresh your memory, a negative times a positive is a negative. But when we have a negative times a negative, our answer is a positive. Okay, so if you want to kind of make a note of that. All right, let's move on. Okay, first distribute. All right, here's the integers again. A negative times a negative is a positive. So 4 times 4 is 16w. And then a negative times a negative is a positive. So 4 times 6 is 24. Okay, so this one I wouldn't say is more difficult than the previous one. It's kind of the same. So just a refresher on the negative rules. So it's the same as above, but it was really showing that a negative times a negative is a positive when we're talking about integers. Okay, all right, let's see what this one does. All right, let's distribute first, so to both terms. Now, 5c times 3c, 5 times 3 is 15. Now, when we're multiplying, and the bases are the same, we keep the base and we add the exponents. There are little invisible exponents here, so that becomes 15c squared. And now 5c times 7, that becomes 35c. Now these are not like terms. To be like terms, they have to have the same variable and the same degree or the same power. So this one was a little more difficult because we had to know that when we did c times c, it becomes c squared. Okay, so I'm making a note something like that. It's more difficult because of those c's, and then 15c squared, that's one of our exponent properties. It's the product of a power. Okay, so let's move on to the back. You should have everything completed on the front side. Okay, on this side, we're going to do the distributive property and combine like terms. So we're going to follow the same process, but it's really like you have to figure out, what are you distributing? So remember, it's that number outside the parentheses. Okay, so in this case, we're going to distribute the -2. Okay, so -2 times 3 is -6x, and -2 times 4, a negative times a positive, is a -8. And then we're going to bring down the plus 8x. Okay, so we've gotten rid of the parentheses. Now we're going to look to combine any like terms. And remember, we always take the sign in front of the like terms. So this is -6 plus 8. -6 plus 8 for the x's. That is going to be a positive 2x. And the constant is -8, so that comes down. So this is our final answer right here. Okay, so this was more difficult because we had to distribute a negative and combine like terms. So you have to be very careful when you're distributing a negative, and you have to keep all those rules sorted in your mind. Okay, the next one looks like, looks a little unsure of what you're going to distribute. It's always that number outside the parentheses. So in this case, we're going to distribute that -4 to both things inside the parentheses. So our 4x is just going to come along. Now, -4 times 2x, that's -8x. Negative times a negative, -4 times -4 is a positive 16. Okay, so now we look to see if we can combine any like terms. Here's some like terms. And remember, the leading coefficient, you want to make sure you know what sign it is. In this case, it's a positive. 4 minus 8. 4 minus 8 is -4x plus 16 for the constant. Okay, so this one was more challenging because what we were distributing was kind of in the middle of the problem. So let's make a note of that. Okay, so I made that note that this was more complex because I had to distribute that -4, which was in the middle of the expression. And also, you had to keep in mind your integer rules and combine like terms at the end. Let's check out the next example. Oh, wow. Okay, so now this looks like we're going to distribute in 2 places. So let's take a look. We always distribute that number outside the parentheses. Okay, and then there's another set of parentheses. So we're going to be doing the distributive property twice. So let's look first. 6 times 2a, 6 times 2, that's 12a. And then a 6 times 1, that's a positive 6. Then over here, a positive 3 times 2, that's a positive 6. And then a positive times a negative is a negative, so it's negative 9a. So step 1, we did the double distribution there. And now we're going to combine like terms. Our lead coefficient is a positive 12. So positive 12 minus 9. So 12 minus 9, that's 3a. And our constants, 6 plus 6. So that's going to be 12. Okay, so more complex because we had to distribute twice and then combine like terms. Okay, so something along these lines. Again, add any additional notes that you feel you need to add. Okay, so distributing twice. We're going to have to do that again here. Now this is going to look harder because we're distributing twice and there looks like a bunch of negatives. Okay, let's start with the term outside the parentheses. So we'll distribute here and over here. All right, here we go. A negative times a positive. That's a negative. So this will be negative 18. A negative times a negative. Negative 3 times negative 2. That's positive 6x. Okay, now over here, always be careful when you're distributing a negative. Negative 5 times x. That's negative 5x. And negative 5 times positive 2. A negative times a positive. That's going to be negative 10. Okay, now combine like terms. Okay, see, we have a positive 6x. Again, you always take that sign that's out in front of it. Okay, so 6 minus 5. 6x minus 5, that's 1x. And then we have, let's see, negative 18 minus 10. Negative 18 minus 10, that's going to be negative 28. Okay, final answer there. So this was more complex because of that double distribution and the negatives. Let's make a note of that. Okay, so I made that note, and just as a reminder, when we're multiplying with negatives, a negative times a negative is a positive, and a negative times a positive is a negative. But then you also have to keep in mind when you're adding or subtracting with negatives, like negative 18 minus 10, that's negative 28. Because that, we're just combining like terms at that time. So that's, important to keep the rules separated in your mind. Okay, so your entire front and back of this distributive property activity should be completed along with the notes. And, hope it's starting to make more sense to you. Please see us if you need any help.